starts. Is it on? Okay. Okay, let's start our meeting. Uh, Good morning, everyone. Welcome to the CAT meeting in IETF 123. And first is about the note well. Uh, Please remember you are agreed to follow IETF process and policies and pay attention to the IPR problems. And the meeting will be recorded by the IETF. And here's about some issues of harassment. So please, um, if you under the issues about it, just say it out confidently. And so here's the meeting tips. Make sure to sign into the session via data tracker, um, whatever you are on-site or remote. So you need to join the queue by the Meet Echo. And for the remote participants, make sure your audio and video off as you are sharing or presenting. And please help to take the minutes together. And this is our agenda for this meeting. We have 35 minutes for the working group document, uh, including the use case requirement, framework, and the metrics. And there will be the hackathon result in the metrics part. And we will have 7 individual draft presentations. So we may not have time for the open discussion this time. So any comments on the agenda? Okay. Here's the document status, the framework and requirements under the RTG early review. And we also get some good comments from it. And for the milestones, we need to focus on the submit the framework and architecture document to the ISG for publication at the end of this year. It's in the November, I think. And next, for the interim, we just had the interim meeting in January this year, focused on the CAS metrics. So if you have any suggestions about it, please send us an email. Um, you can pay attention to the points that has been discussed in the main list, including the unpass issues or others. And for the use case and requirement, the goal is to go to the last call before the end of this year and to solve the problem on the list. And it is same for the framework document. And for the metrics, we're open to have more comments on it. Okay, for the individual draft, please remember that one of the goals is to serve as input to the work group draft, or it is clearly address charter work or clearly related to CAS. And you can pay attention to the charters about the additional groundwork or the analysis of existing tools and mechanisms part. And please remember to using the mailing list to discuss. Okay, now we can go into the first presentation, CAS use case and requirement. Go ahead, please.
Hi, everyone. I'm Kern from China Mobile. Thank you. So I will going through the major updates since IETF 122. So yes, it's a quick summary of the updates since the last meeting. So we have um, major updates from version 6 to version 7. So we have addressed comments from the early review from routing area from Ines Robo's comprehensive review. Many thanks to Ines. And then we have integrate comments from Agent and comments from Paul. And then the comment, we also receive some discussions and comments in the list, primarily on the use cases from Carlos and Trent. So, but since some of the discussions are still ongoing in the main list, we will integrate the updates in the next revision. So here are all the updates on the requirements. We're going through all the updates. So in the first part in section 5.1 on requirements instance selection, so basically all the updates have been marked in red. So for requirement 1 and 2, we have add more descriptions on dynamicity. That is, the dynamicity, it means that the discovery and the resolution methods must be dynamic, as well as the assessment of the availability of service instances. And then we further explain about the dynamicity. It's based on real-time system informations and also up-to-date status matrix. So, and then in section 5.2, on requirements and matrix representation definition. So, and next page also on section 5.2. So R3, we have clarified the subject of these requirements. Uh, the subject are the implementations rather than like implementers or like service providers. And also we have clarified the applicable scenarios or conditions. It means that the implementations, the requirement that applicable to this implement the requirement will be applicable at both design time and runtime. So these are according to the review from the routing area reviewers. So, and next, still on the requirements of matrix definition and the representations. So R8 is a new requirement. And so it defines a staleness handling method. It means that cast components must know that if a matrix value is valid or not. So this requirement we think is necessary to be added because it just responds to the dynamicity and defined in R1 and R2. So I think it's a reflection about this stillness handling. And R9 defines, we further, add some, the method, how the CATS matrix can be understood by components that it must be produced and encoded in a format that can be, so we have provided some supplementary explanations. And R10 is also a newly added requirement. So for all of these requirements, only R8 and R10 are newly added. So R10, it means CAS components should support a mechanism to advertise or negotiate supporting matrix types and encodings to ensure compatibility across implementations. So we think even R10 is a should requirement, but we think it's a requirement that can be applicable to all of the use cases. So we think it's also necessary to be added. And then R11, we maintain this requirement. And so basically a quick summary on section 5.2, the requirements, the refinement on the description of, we have some refinement on the description of CAS matrix encoding, attachment, and the validation. And then go to section 5.3 on how we use CAS matrix. So before the requirements update, we have also provide some complementary description on matrix distributions. And also we have added some concrete examples on for example, on the choice of signaling protocols. And also we have considered some possible solution choice. So maybe we think the newly added description can be guided for future protocol design or solution design. And then R16, so many thanks to agent. So this description is modified and refined by agent. So it kind of adds some refinement on this. So it means that the CAD system must not be sensitive to update frequency of matrix, and also it must not be dependent or limited to specific solutions. And then we go into section 5.4 and the fourth part on instance affinity. So this part we have provide some refinement on instance affinity requirement. Like the R18s, we have explained that this requirement is applicable to like both transport sessions and also application level transactions. And also we have provided some requirement on other other requirement like we have deleted some unnecessary explanations like keeping fine-grained as runtime state granularity because we think it's very hard to measure this. And then for R22, we have um, refined it like we need to support service continuity in the presence of UE or service instance mobility. And then for the security considerations, we have provide some detailed descriptions regarding security. For example, like R25, like the nature of the user activity should be protected to preserve user privacy, including minimizing the exposure of identifying or behavioral patterns. And also like advertisements, we have mentioned that it also cover both authentication or encryption. Both need to be, is considered in the security. So a quick summary that for the next step that for consolidation use cases, we have discussion in the amenities. And also, I personally I recommend adding a new subsection referencing related work in other SDOs, but not in details. We will not consider to add new use cases. And also for requirements, like if you your draft mentions service specific requirements, so we don't recommend to be added it into the existing document because these requirements might not be applicable to all of the use cases. So we suggest you can go separately, and this can be better considering the stability for this document as well as the framework document. So for future extensions, we are still very welcome for individual drafts to go separately, and then we can, to think, cats and also for future extensions. And for plan of this document, we plan to ask for working group last call after this meeting together with the framework draft. And yeah, this is a major updates since last meeting. And any questions?
Thank you for that. And it's really nice to see that this document is consolidating.
Yes.
I want to take the minute that's left to just remind the working group that additional use cases are really interesting, but we are not trying to document all use cases in this document. What we're trying to do is collect all requirements, and in particular, general requirements. So as people come up with new use cases, please go back to the list of requirements and see, do the requirements already documented cover your use case? If they do, great. If not, flag it. Erin.
Thank you. Can you hear me?
Yeah.
Yeah.
Thanks. Erin Welling, Oxford Information Labs. Can we please, I have 3 slides that I want to ask some questions about. Can we go to page 4, please? We'll start with 4. Thanks. So there's a bullet that talked about ignoring things that are not formatted. Where was that? Oh, here it is. Yeah, bullet. Yeah, R9. So let's look at R9 for a second. Okay, it talks about the last sentence says for metrics that CATS components do not understand or support, CATS components will ignore them. Yet the next bullet says advertise or negotiate, right? Supported metrics types and encodings to ensure compatibility across implementations. So I don't know if you mean by implementations as in CATS only implementations, but this seems to be going against the concepts of interoperability, right? We're talking about literally ignoring um, networks that are not using cats. Is that my understanding from reading 9 and 10? That's just my first question. Thank you.
Um, um, I'm not sure I understand you correctly. So you mean your concern is about implementations is whether it's limited within CAS only or can be extended to like other technologies. Do I understand you correctly?
Yeah, I'm just trying to understand, how does cats work with environments that are not cats based?
Yes, actually, uh, even we are thinking that can be can be extensible because we want CAS to be applicable to various use cases. So actually, yeah, we want these network components, the CAS component. Yeah, these requirements are defined that to limit it in CAS components, but does not mean that the CAS can only be used in very limited scenarios. We want CAS to be integrated with other routing area technologies. So yeah, here the limitation implementation here is only for CAS, but it does not mean that all of these requirements here will applicable to CAS only, right? I mean, yeah, CAS can. We think CAS can be, tended to work compatible with other like routing technologies
Thank
or
you.
other
So
TLS.
please,
Thank you.
if you don't mind, please adjust your requirements to say, talk a little bit about the extensibility, because I didn't really get that from just these
Okay.
bullets.
Okay. Thank you.
Yeah, I think we need to understand whether CATS is only going to be able to handle, uh, uh, you know, uh, information that's flowing through CATS environments, right? As soon as you leave try to integrate with any other environment, it totally bypasses any capability that it can do. It actually almost starts to head towards some kind of proprietary um, type concepts of encoding
Yeah.
where there's no interoperability. It's assuming that everybody adheres to their format.
Okay.
If that's the case, then we need to make sure we make that very explicit so we know the limitations of cats. Um, and let's be very open and honest about that. If it truly is counting on um, a cats only environment, then we need to state that. Okay, so we understand limitations. It's not only about capability, but it's also about limitations. So we
Okay.
can.
We'll find a place to talk about the extensibility of CAT in the
Thank you.
requirement.
Can we go to page 5, please?
Sorry, page.
The next one, please. Thank you.
Next one. Okay.
Thank you. So this highlight on the right-hand side, it talks about API for publication of CATS metrics to a centralized decision maker. Okay. I think we need a diagram or something because need to understand what kind of throughput we're talking about if there's a centralized decision maker. Where are these decision makers? Where's the uh,
Yeah.
overhead that's associated with making these decisions? So where does it fit in the architecture?
Okay,
Yeah.
so Erin, you have to look at this document alongside the framework document.
Yes.
Okay. Okay. So there's a central. Okay. That's fine.
Yeah.
That's thank you for that response. I will do that. And the next one is. Can we please go to page 7? Okay. So yeah. Yeah. Exactly. Okay. So I'm a little concerned about this wording of minimizing the exposure, okay, of identifying and behavioral patterns. I think there's a difference between minimizing and not allowing. Okay, so um, I understand that the intent is to minimize, but because we're talking about something as important as behavior pattern, okay, and identification, I think we need a little bit stronger language that this will not allow for exposure of identifying and behavior patterns as opposed to minimizing. Minimizing means there's still leaks, okay, in my mind at least. So it's too, I don't think it's strong enough language. Uh, of course, if that is what it's doing, that there is the opportunities for behavior pattern exposure, then it needs to state so. But minimizing seems a little bit weak to me. Thank you. Thank you.
Yeah, thanks. Cool.
Hi, Carlos Bernardos from University Carlos III Madrid. Just to follow up on your comment that you did at the beginning on the ISAC use case that was being considered, and also following up on what Adrian mentioned, I would like to ask, when are you going to decide whether to add it or not? Because I think I follow, well, the ISAC use case was presented in the past, then I follow up on Adrian's recommendation or suggestion on we are only going to document what adds new requirements. I posted some new requirements specific to the ISAC that may apply to others. That is basically having multiple sources of traffic, then steer to some node. There was some discussion on the mailing list. Joel, I think, was saying that maybe too complicated to be considered at this point. There were other people supporting. I think it's worth documenting that, even if potential solutions in the future don't address all the potential requirements due to complexity, but I think that's something worth being documented, and that's why I'm asking, because if you plan to go working group last call, this should be added before.
Hi, Carlos. I think I have replied to your. I've sent you an email. I'm not sure you have received it to the mailing list. So
maybe not.
Yeah. I think I shared some of my thoughts on your draft as well as another individual IDs. So inside your ISAC use case, I think the use case is wonderful, and also CAS can be applicable to ISAC use cases. But only one requirement I think is service specific, like you mentioned about data synchronization within CAS components. So yes, we think for future solutions, adding these specific requirements is hard. And also this requirement might not be applicable to other use cases listed in this document. So based on this, so we think we might not add this requirement inside this document, but we welcome this individual document of ISAC to go separately. And also, as I suggested here, we can also add a new subsection in the use cases section, like mentioning some, relationship and related work, like mentioning other SDOs, not merely just ETSI, but also like 3GPP, so we can have better, coordination with other work. So yes, but for, requirement, I think for personally, I don't recommend the data synchronization part to be added. But for others, I think if you can have new requirement that can be applicable to, you know, major use cases in the document, I think it can be added. But yes, if not,
follow up on that will be that I think it's worth, and with that I will close. I think it's worth documenting use cases in general if they are very much into this. It's true that probably the only one that is specific to ISAC is that one, but there are others. And I don't think the other use cases, all the actual requirements they will have are going to be requirements that the solutions at the end mandatorily will support. There will be some that will be optional anyway. So that's why I don't think the argument of something that is maybe hard to provide or not is a reason not to include when the case is clearly in a scope. There is something specific, but some other things that are also covered already in the framework. There are other SDOs working on this, 3GPP and ETSI. So excluding a use case that is considered by others, there is even a work item in ETSI to consider the compute, so something very CATS specific. To exclude that, I don't see the reason. I mean, that's my personal opinion. Of course, so, and this thing about the ETSI having a work item working specifically on this and then excluding, to me, conveys the wrong message to, for example, ETSI. It's like, we don't care what you are doing. In the working group that is specifically working on compute awareness and these aspects, we don't consider the use case that in ETSI there is a work item specifically working on that. that's my follow up on this. Of course, is the working group to decide, but I think it's worth
Yeah.
saying that.
Yeah,
So,
so if the, if the authors and Carlos want the chairs to help call some
Yeah.
decision on this, then drop us an email
Okay.
saying, you know, we need help with this specific question, and then
Okay.
the chairs will drive it.
Okay. Thanks.
thank you.
Okay, good, thank you. So we're on to the framework.
Hello, everyone. I'm Charlie from Hawaii. So, yeah, thank you. So I would introduce the, yeah, thank you, update of the CATS framework. And the good news is that after the previous meeting, we actually update 6 revisions of the framework document, which is very good to me, yeah. And uh, mainly we have 2 parts of today's presentation. The first one is about the changes introduction uh, after the previous IETF meeting, and then we can have some discussion of what is the next step. Yep. And here's the update introduction of revision 05207. We actually addressed the comment from Adrian and Zhongpeng about the joint affiliation and some, terminology definition, like what is we deleted overlay of the cats forwarder, and we also make some, editorial modification of the text and figures accordingly. Yep. And for the revision 6 to 7, we addressed comment from Matt and Chang Wang, and we explained how to implement the service instance. And we also confirmed with the Chang Wang that his comment has been, addressed. And regarding the update from 7 to 8, and we are very happy to receive a lot of comments from Ines, and very thanks to Ines review. And we accordingly we added a new term called flow, and then we also specify what is the provider in the draft. We make it as a service provider, and then we also add some text to introduce what is the ingress cast forwarder. In the previous revision of the draft, we haven't have a uh, introduction of what is ingress cast forwarder. We only have the text for egress cast forwarder. Yep. And then I will not repeat the details. Yep. And then for the revision from 08 to 09, actually we addressed the comment from Matt. Yep. A long time ago, we have a to-do list, a to-do task, uh, which should, which is about adding some text of provisioning. And in the end, yeah, thanks to Matt, he proposed some text to of this part. So we finally addressed the comments of regarding provisioning. Yep. And the second one is that because we forgot to, add Ines into the acknowledge, so we add her into the acknowledgement section. Thank you for her review. Yep. And then regarding the revision 10 and 11, actually we fixed, the problem of using the deployment models before the definition, because we moved the text from uh, how to say, yeah, from this section up to the later section, so caused some problems. But actually, anyway, we fixed that. And then we also add some text to address Matt and Adrian's comments regarding the, management section. So we add some text about verifying correct operations and impact on, network operations. Yep. And for the last update, we address the comment from Adrian again, yeah, from the last ITF meeting. The first one is about who or which association or which how say entity uh, associate the service ID with the service, and we clarified that in the new revision already. And then the second one is about the metric classification and agreement aggregation. Yep, we discussed with the order from the metric definition draft, and in the end, we moved the text from the metric definition draft into this document, and which is a good work. Yep. And currently, we still have 3 issues, all came from Zhongpeng to be addressed. But luckily, when I went through the, the issues, I found it is quite easy to address. Most of them are, editorial comments. So hopefully, we can address his comment as soon as possible after the meeting, and then we can move into the next step, which is about the working group last call. So right now, regarding the next step, I list some key information here. So first of all, we need to address all the issues, right? So right now we have 3 issues, and if you have more issues or comments, please go to the list. Yep. And then once we address all the issues, then we can have some discussion about these 2 points. First one is service announcement, and the second one is security. We only have 3 minutes, sorry. So yeah, now it's for discussion. Yep. If you have any comments regarding the service announcements or security part, welcome. Yep. That's it. Thank you. 3 minutes.
Brilliant, thank you, and thanks for being quick. I'm going to be coming to you on this draft to talk about operational considerations and what we need to add, but we can deal with that offline. Any questions?
Uh, just one comment, please make sure it is clear that between the service metric and the company metrics. I see in the, you change some service metrics to company metrics, right? In the text.
Yes.
Yes, please make sure that everyone knows the relationship between it.
Okay, good.
Okay, Jim?
Hi, my name's Jim Reid, and I'm a DNS geek. I'm not a routing geek. So anything that talks about changing the DNS system, frankly, scares the hell out of me. And I think it should be very, very clear that anything you're doing here is not going to change the DNS. Because if you try to make changes here, this is going to have far, far reaching implications in terms of interoperability and standardization implementations. So please, please, please take your energy and focus them elsewhere.
Thank you. Thank you.
An anycast IP address approach is clearly better
Yeah.
than messing with the DNS.
Yeah. Personally, as author of this document, I agree with you fully. And I saw the comments from Joe as well. He fully agrees with your point as well. So I agree with that. But as a working group, we might open some opportunity for some innovation and discussion. I'm good with that. Yeah.
Okay, just one final point. I'll make a shameless plug. There's a DNS directorate, and it's supposed to review all internet drafts that have any kind of DNS content in them. So if anything comes out of this working group that does have any kind of DNS elements to it, please chuck the drafts across to the DNS directorate early in the process to get feedback and guidance before things get too far developed. Thanks.
Good to know that. Yeah, thank you. Yep, it should be done. Yep. Any comments? Oh, yeah.
Oh, Daniel, please.
Daniel Huang, ZTE. About the DNS, actually, I personally strongly believe cats and the DNS would better to coexist peacefully. So I also suggest we using the existing anycast IP address as the computing service ID rather than we employ a larger standalone mechanism. That's going to be a lot of complexity.
Good to hear that. Thank you.
Okay, thank you. Next, about the metric. Jody, please.
Hi, this is Jordi from Qualcomm. Now I'm gonna describe the updates for the CATS metrics document, and of course this is in collaboration with all the authors and yeah, here in the list. So the main updates for this since the last IETF is addressing comments from Julian and Dirk. Um, we added a new section on the design principles, focusing on Y3 metrics, Y3 metric levels in the design. I'll touch on that in a couple of slides. We also, there's comments from the chairs, also from IETF 122, removing the part, the implementation guidance on using CATS metrics, since that part has been moved to the CATS framework document. Also, on the new section 5, we provide a comparison among metric levels, an analysis of encoding complexity, extensibility, and stability. All right, so the first one was on why the proposal is to use 3 metric levels. The trade-off here is one of complexity. The more levels we have, the more complex is the specification, the implementation. But at the same time, the more flexibility it provides also, because if you only have, like, say, one level, the solution doesn't really provide the necessary flexibility uh, and scalability at the same time. So that trade-off is met, we think, at about 3 levels. So going from one level to 2 levels, you get already a benefit. The upper level is a single metric that gathers all the metrics and provides a single metric to the application or the operator. But within that middle level, what we call the level 1 metric, allows for that level of flexibility. So if we consider, for instance, suppose that we had only a 2-level solution, you would have at the bottom hundreds of or thousands of level 0 metrics. At the top, you would have a single metric, coalescing all the metrics into a single value that you would provide to the operator. Uh, that itself is, we think it's too rigid and deserves a little bit of more flexibility. And that's, so going from 2 levels to 3 levels, you get this benefit of significant flexibility, because now at level 1 metric, you can gather level 0 metrics, um, uh, for instance, based on compute metrics or communication metrics. We're discussing also adding another level 1 metric about service metrics. It provides a more structured way um, at some reduced cost, right? So adding a level always adds cost, but we think that that's manageable. So this proposal, we think, meets this trade-off of complexity and flexibility at 3 levels. If anybody has a different opinion, of course, we can always discuss this, but that's the rationale behind the design. We also naturally incorporate this concept of aggregation and normalization functions, which in a newer version we will be formalizing into a section, but I thought it would be good to express here in case people have any feedback. But as we were going through the metrics, we realized that there's a need for defining what we call aggregation functions and normalization functions. What are these? So an aggregation function is one that takes as an input several metrics, so say up to n metrics, and then as an output, it generates another metric, basically. So from n metrics, you aggregate them into a single metric. An example of this could be the mean average, or simply summing up all the metrics to obtain a single result. Instead, on the other hand, a normalization function is one that takes as an input a single value, which usually has units, bits per second, or latency like in seconds, and takes as an output a unitless score. It normalizes that. And an example of normalization function could be the sigmoid function, which takes any real value and returns as an output a value between 0 and 1. Think of it as in a score, basically. So we think that providing for both aggregation functions and normalization functions, these two kind of building blocks facilitate the process of defining these metrics and also going from one level to another, right? So for instance, you can compose a level 1 metric by aggregating multiple level 0 metrics. And at the top, maybe you want as a level 2 metric, one that is normalized, that just provides a score from 1 to 10, say. Okay, and then we have a couple of questions that we brought to the mailing list. We got, I think, a response from Chen, so thanks. But we thought it would be good also to open it up. So there is a conversation about should we introduce a new level 1 metric called service metrics. So we're thinking about, in terms of level 1 metrics, to have a class called compute, another for communication. Um, uh, and we also thought about one which is called compose metrics. And we're discussing whether to add this fourth metric type called service metrics, because there are things that are not necessarily compute, bound to compute or communication, things like system availability or queries per second or tokens per second, which extend beyond compute and communication. So that is question number one. And the second question is whether, how far we should go in terms of standardizing the metrics. And in particular, should we standardize things like the size of the metrics? So currently, the document only provides examples for each metric level. Should we standardize these fields? At which level? And should we also standardize the size of each field? How do people think about that? I think that covers my presentation, so we can open up for conversations.
Yeah. John, please.
Yeah, Chun-Li from Huawei. Regarding the first question, I would say yes. But we need to add some text to explain what is the composed metric and what is service metric, because sometimes it's hard to distinguish them, right? So this answer for question one. And for Q2, question two, I would say yes again. We definitely need to standardize the size of, especially for the L2 metric. Yep, that's all. Thank you.
Mm-hmm. Yeah, I think you made a good point. So how to differentiate between service and composed metrics. Maybe this is a renaming proposal to change, instead of composed metrics, we could call it service metrics, or maybe it's to separate. So that's, yeah.
Daniel Huang, about the second questions, I would say it depends on the specific protocols or interfaces we would use to propagate the metric, the service metrics. Because let's take example of BGP protocols. So if we want to make it consistent with the existing protocol mechanisms, we have to make sure the service metrics, as you mentioned, it fails to boost, it fails to, their sizes to, are consistent with the metrics of the protocols we would utilize. And about the first questions, my personal opinion is yes, but I'm quite confused. Under CAS architecture or under the CAS working group, of course, my question may be for the chairs. Do we need to standardize the kind of aggregation as well as normalization of the metrics? Because I believe as kind of as internal implementation from different vendors, something like this, or we simply need to standardize the service metrics itself. Thank you.
Yeah, so we certainly do not need to standardize algorithms and mechanisms for aggregating metrics. What we have to make sure is that when a metric is advertised from one place to another, both ends have the same understanding of what they're talking about.
Thank you.
Very good. So moving on to the hackathon.
Yep. Right.
Hello everyone, this is Luis from Telefonica. I will report the results from the hackathon. So during the weekend, we spent some time on trying to exercise this collection of metrics, this aggregation, and I will basically report the results. This was done together with colleagues from University Carlos III from Madrid and Polytechnical University of Madrid. All of us, we are working in this Codeco project that we just will use for reference so that you understand the setup that we use. So basically in this project, we are working and trying to exercise an integration between the cloud and the network. For the cloud, we are using Kubernetes, and there are different components that are in charge of deploying and instantiating the workloads around. And there is another component that is the one in charge of interconnecting those pods. So we leveraged on that setup so for that we were able to collect metrics from both sides, compute side and network side. For the network, we were using props, dynamically instantiated as well, and running active probing in the connection. So collecting a number of network metrics like bandwidth, latency, and so on so far. And for the Kubernetes side, we were collecting essentially the information that Kubernetes provides for the compute resources. As said, we exercised this aggregation that Jordi just presented, and I will go directly through the results. So we started to collect layer 0 metrics. On your left side, you can see metrics about bandwidth and bandwidth, I guess, or latency, latency, I think, or bandwidth. The bandwidth was essentially a bit per second. The latency was latency, microseconds, and so. And in the bottom graph, we use here for representing the results the CPU, the idle time of the CPU in one of the worker nodes. Okay, this was basically done in a virtualized environment, so running in a PC. So this is why somehow it's a kind of toy example, right? But interestingly here, if we look at the layer 0 metrics from the compute side, we see a great variability, let's say, of the metric along the time. So this is something interesting to understand and to process, and maybe from deriving from it the need of somehow aggregating the metric before being used. And we will see the reason why. So then with all the metrics and thinking on one specific node, well, I forgot to say that we were using one master node and two worker nodes. So we are starting to aggregate the different metrics. In this case, you can see here in the graph latency and bandwidth. So we created a toy formula, just basically dividing the bandwidth by the latency, just for creating a kind of aggregation. So a pure toy example. And again, we can perceive somehow variability, and yeah, probably from that we can derive as well the need of having kind of a averaging period or so for having metrics much more stable. We normalize the metrics in this case with some spurious metric there exceeding the one, but basically a consequence of the measurement. And finally, we reach this layer 2 aggregation of the metrics. Remember, we had 3 nodes, the master node and the worker nodes, 2 worker nodes. And we here basically merge the score from the CPU, the idle time of the CPU, and the bandwidth and latency, the result that we saw before in layer 1. What we also interestingly here to remark is the fact that, as you see, there is only one continuous measurement. There are 2 others that are somehow broken. And this is why in some point in time, the measurement of the CPU, the worker nodes, were not available. So this also can make us to think on the fact that how to proceed once we, in all this aggregation exercise, will miss some part of the metrics. So somehow probably we need as well to provide some guidance on what to do in this case so that the metrics are not corrupted, let's say. So this was what we did, and yeah, basically, if there are any questions on this respect, we are glad to answer as well.
So thank you. I'm really glad to see hacking going on around cats. It makes us feel that maybe we're doing something useful. And please keep us posted with how this develops.
Okay, wonderful. Thank you.
Okay, so I think rightly we gave more time than planned to the working group drafts because we wanted to keep those moving forwards. We now have 7 individual drafts to fit into the remaining 39 minutes. So I'm going to ask everybody to try to do this in 6 minutes. And if you manage to come in 5 minutes, you get chocolate.
Hello, everyone. This is Zhuan Sheng, and I will present the data model for the cats on behalf of the co-authors. So this is the centralized architecture for CAS system, and there will be two kinds of the interfaces for the CAS, such as the CAS SBI and the SMA API. The CAS SBI is used to report computing service information from, for example, the CAS forwarders to the CAS control center. The CAS control center may include the management plane and the control plane. And it also could be used to send pass and the service policy information or computing service information to the from the CAS control center to the CAS forwarders. And for the CSMA API, it is the interface between the CAS control center and the cloud managed platform, or between the CAS forwarders and the service instance. It can be used to report computing service metric to the from the CAS controller center and to the CAS forwarders. This is the centralized interface from the architecture. So to state the issue the CAS data model structure, we have defined the three kinds of young model for the CAS young. For example, first one is the control plane young. It consists of the base configuration young, traffic classifier young, and service metric young. And for the forwarding plane young, it will include the forwarding paths young and flow entries young. And the last one is notify young. So in details, first one is the CAS base configuration young, configuration tree. It may be used for the CSMA API and between the CAS control center and the cloud management platform. It also could be used for CAS SBI between the CAS control center and the CAS forwarders. For example, it will include the base, and it will consist of the enable, the update interval, and entry names, flow turn out, service policy, and the service policy will identified by the CSID and the policy type. And the second one is CAS traffic classifier tree. It could be used for the CAS SBI between the CAS control center and the CAS forwarder. It defines the feature of the service and classifying the traffic. For example, it could include the CSID, the description, and the server port and the protocol type. So, and the surface metric tree, it can be used for the CAS SBI to forward service metric information. It also can be used for the CSMA API to transmit the service metric from the cloud management platform to the CAS control center. For example, it also the service metric will cover the CAS service metric. For example, they cover the optional entities. For example, the CSID, CIID. It will be changed. It will be aligned with the framework. And it also includes the source type, the priority, the availability, a location metric, and metric type. The metric, it will also be updated to align with the metric working document. And for the CAS forwarding path tree, it could be used at the CAS SBI for the CAS control center to distribute forwarding table entries. It can be used for forwarding service traffic on the data plane. And for the multiple paths, node balancing also can be achieved based on the assigned weights. So it also, for the forwarding path, it also will carry the CSID, CSCIID, policy type, weight, forwarding path state. It also include the path ID, forwarding path info, and it will include divided into last hop address, interface, and the data plane type. And the forecast flow entries tree could be used as the CAS SBI for the CAS control center to distribute forwarding flow table entries. It can be used to report flow statistical information to the CAS control center. The flow entry will also identified by the source address, desk address, source port, destination port, and the protocol. And the forwarding path will also be identified for the CSID, CSCID, availability, forwarding path info, and the last one is the flow statistic. Next is the notify tree. It could be used at CAS SBI for the CAS forwarder to report events to the CAS control center. For example, it will notify the entry limit and the flow limit. So that's were the young data model, and we will update to align with the framework and the metric documents to improve the young model. So this is the first time to present, and we lead more review and feedback. Thanks.
Okay, thanks. I encourage discussion of this on the mailing list and for you to keep pursuing it with the other work.
Okay, welcome to further discussion on the mailing list. Thanks.
Make sure the terminology is right based on the architecture and the metrics.
Yeah. Okay.
Okay.
We'll
Thank you.
update in next version.
Okay. Thank you. Next. Just wait. Yes, please.
Okay, can you hear me?
Yes, we can hear you.
Okay. Hello everyone. I'm Wang from China Unicom, and our topic is security considerations for computing-aware traffic steering. Sorry, I can.
You can control slides.
Yes, I can control the slides. Can I share my own slides? I have made a little change.
Okay.
Sorry.
Have you tried to share the slides?
Can you see the slides? Sorry. We can transfer to the slides.
Just try again.
Okay. Okay. The next page. Okay. Sorry. Can you see the slides?
No, we can't see it.
No, sorry.
So I suggest to you, yes, I will share it again. So uh, maybe you should talk based on this version, I think.
Okay, the next page. This is the revision 02. We have made a big improvement on the basis of the framework of the revision 01, and uh, there are mainly five aspects of the potential risks of a CAS. The first is the security issues of computing resources. The second is about the computing past lecture. The third one is the computing service announcement related security issues, and the fourth one is the matrix distribution security issues, and the last one is sorry, there's some mistake is about the security metric. Next page. Okay, the first one, the security issues of the computing resources. We have proposed some potential risks, such as the unauthorized access and control, and data confidentiality breaches, and as well as denial of service rights. And we also propose some possible countermeasures, which includes granular access control, secure communication frameworks, as well as the resilience against the DDoS and continuous monitoring. The next page, please. The second one is computing past lecture security issues, where we propose some potential risks such as path manipulation attacks, convert channel exploitation, topology poisoning, design logic corruption, orchestrator impersonation, uh, and the corresponding countermeasures are also proposed in this document, such as the authenticated path metadata, decision integrity protection, as well as some technology, such as differential privacy for path selection, and so on. The next page, please. Um, the third one is about the computing service announcement security issues, which includes potential risks such as unauthorized announcement injection, sensitive information exposure, replay, or reuse of legacy announcements, and identity spoofing, as well as DDoS through announcement flooding, and the corresponding countermeasures such as cryptographic integrity protection, metadata minimization, anti-replay mechanisms, rate limiting, and identity verification. And next page, please. The fourth one is matrix distribution security issues, which includes potential risks such as tampering with metric data, eavesdropping, unsensitive metrics, flushed metric sources, privacy violations via aggregation, and also there are some corresponding countermeasures such as end-to-end integrity protection, confidentiality preservation, self-authentication, privacy-aware metric design. On the next page, please. The last one is about the security-related metrics. We think that the service and the network metrics could include some security-related capabilities, which could be used by the CAS path selector to compute paths with security guarantee. And the last page, please. Okay. Um, um, Welcome sharing your insights on enhancing the security aspects of CAS. My question is there any Are there any suggestions on security analysis and measures outlined in this document? And the second question is, if the document covers all the critical aspects of CAS security, or if the additional measures should be addressed. Thank you.
So thanks, Krikri, for doing this security work. While we move on to the next set of slides for the next presenter, can I ask you to look at the security sections in the framework and the requirements and see whether there's material to transfer from your draft into those two working group drafts to make the security there better.
Okay, thank you.
Hello, can you hear me?
Yeah, we hear you.
Oh, thank you. So this is a discussion about service segmentation on CAS, and I'm Mingok. I will present this presentation. We go to the next slide. So I previously introduced service segmentation in deployment practice that splits the service into multiple subtasks, and these subtasks need to be combined in parallel or in sequence to realize the full functionalities of the original service. So in this meeting, we discuss two realistic CAS use case example where service segmentation can be applied on. The first one is XR rendering service pipeline, and the second one is distributed AI inference pipeline. So we see how service segmentation will affect the CAS system. Please go to the next slide. The first example is XR sequential rendering pipeline. This is taken from the recent GVP report on 6G use case and services. As you can see that the XR rendering service can be split into the sequential subtask pipeline of rendering engine, then to engine adaptation, and render acceleration. Each of the subtasks can have instance on multiple next slide. You go to the next slide. So talking about the CAS objective. So in this case, we are not select an optimal service instance. We select an optimal pipeline instead. So the optimal pipeline consists of an optimal instance for each subtask or subservice in the pipeline. Now after selection, we route the packet in the correct order. Please go to the next slide. Second example, vertical ML model split parallel inference. If you look on the right figure, an ML model can be split in two ways. First way, horizontal, based on the layer. Second way, parallel, based on the dimension of the layer. So in the first way, horizontal split, we have the sequential pipeline like the previous one. But in the second case, vertical, we have a parallel pipeline. We go to the next slide. Then the culture objective here is also shown. It's not selecting the optimal service instance. We have to select an optimal pipeline. Again, one optimal instance for each of the ML model slide here. The request input need to be preprocessed corresponding to the each ML model slide input requirement before being steered to this slide in parallel. We go to the next slide. So with the example analysis, this is a three CAS system decide that the service segmentation affect the CAS system. So we're talking about it because as AR/VR and distributed AI inference are listed in the CAS use case. So CAS system design should fully support scenario when service segmentation can potentially apply to the case. Then the first consideration point, traffic steering objective. As you see in the previous example, we are not selecting a service instance. We have to select an optimal pipeline. Consider optimal instance each subtask composing this service. So I agree that many discussion that introduce the subtask concept might cause a lot of change. So we can explain the service segmentation in a better way, like a pipeline or service might be required to rely on application requests. So in that case, CAS can still cover the service segmentation concept. Please go to the next slide. So the second point is traffic steering mechanism. So it's only applied to the sequential case. In this case, packet might need to be routed across multiple CAS forwarders. And the third one is the CAS matrix aggregation. So if we have to select an optimal pipeline, so between different pipeline candidates, to represent a candidate pipeline, we might need to aggregate matrix from the component service. So it's a new way of aggregate the matrix. We go to the next slide. So our suggestion, as in the mail discussion, we agree that the service segmentation is only an optional service deployment method, and the CAT design impact can be the implementation requirement, not the general requirement. However, I agree with the author of the use case ID that a brief paragraph inside the ID that mentions that certain optional and service-specific deployment models can raise additional CAS system level design consideration might be benefit to the draft to make it flexible for future proposal. That is for my presentation part. Thank you.
Very good, thank you. Thanks for being on time. And we'll have discussion of that on the mailing list and move on to Marco. For everybody, we're down to 4 presentations left in 20 minutes, so that's 5 minutes each, I'm afraid.
I will do that in less than 5 minutes. All right. Hello, everyone. I'm here to make the CATS working group aware of work that we progress in the distributed mobility management working group. And in the past, we heard sometimes, so bring this to CATS, maybe they can leverage it. It's about mobile traffic steering. So brief background and motivation. Mobile communication systems are not end-to-end, full stop. So some use cases, in particular advanced scenarios that are being discussed, demand for more alignment and control of end-to-end traffic steering. So that's what we do in this draft, and we extend an interface that extends mobile communication system towards the transport network and towards the data network for mobile traffic steering. We discussed that a couple of times and a long time ago, had a public site meeting. So the current draft is very clear in its scope and interworking options. We specify use cases, exemplary use cases to make clear what this is made for, deployment options, and currently information model, which can be progressed towards data model areas. Thanks. Next one. So the reference architecture we have is taking an abstract mobile communication system, which we don't want to interfere with. We want to complement it, right? But having a mobile control plane and a user plane anchor for the user plane. On the right side, you see a data network, which has instances of application service functions and maybe also control functions. In between, there is a transport network with data plane nodes. We support flexible constellations of data plane nodes that serve user plane anchors on mobile communication side and data plane nodes that serve the data networks on the other side. Next slide, please. Some use cases you may see in the slides or in the draft in particular, but user plane anchor relocation in the mobile communication system, it's a well-known scenario. If you do that and have some requirements on service continuity, you need to steer traffic accordingly. Multiple UPAs serving a mobile node, in particular node ephemerality. It's an important aspect in the view of future integration of non-terrestrial networks, satellites, but also energy-driven nodes that may go down because of an energy saving schedule. So that's all scenarios that we discussed. Next slide, please. So that's most important, maybe, which is that we specify semantics applying to an interface that we call CMTS, and that applies in 2 different ways. First of all, if we have a dedicated controller in the transport network, which we call mobile traffic steering controller, the interface applies to the mobile communication system control plane. And the second one is a more decentralized approach where no dedicated controller exists in the transport network, but mobile communication system control plane enforces policies to the user plane anchor, which leverages that API to talk to a data plane node to propagate routes according to a routing protocol like segment routing, BGP, whatever. Next slide, please. So we have 3 different modes. Very quickly, this is a dedicated controller for mobile traffic steering. And each of the controllers in the transport network and the mobile control plane applies the policies to their data plane and user plane node. Next slide, please. Then the other extreme is a decentralized operation where the routes in the transport network get all the information through the specified API from the user plane anchor. And third mode on the next slide is mixing both of them. So you see the mobile traffic steering controller has no interfaces to their data plane nodes, but leverages the API to get information from the user plane anchor. Next slide. All right, this is the structure of the draft. Please have a look. Today I heard a lot about metrics that you take for computing traffic steering, computer-aware traffic steering. So I'm pretty sure for mobile deployments, this draft and API may be useful, and the interface semantics that we specify is also something that we could align with this group's work. And if you need help for the use cases in terms of mobility management, interworking, I'm willing and available to help here. Thank you very much.
Thank you. Well done. Less than 5 minutes. Chocolate award.
Wow.
And next up is Lewis.
Yeah, I will cover this scenario about the applicability of the intersection between CATs and mid-haul networks. So in the past, this draft was presented, and basically we identified some requirements basically. So that part of the requirements, the idea is for sure transferred to the use cases and requirements draft, and here focus more on architectural implications. So very briefly, for those not very much familiar with the ORAN activity, what ORAN is looking for is basically to define or to standardize all the architecture of the radio functional split. So dividing the baseband processing in radio unit, distributed unit, and centralized unit. The radio unit is the antenna. The distributed unit will be in charge of the real-time processing of the radio signal, and centralized unit on the non-real-time of that processing. So these functions are distributed internally into the network, and then we have connectivity among them. So between the radio unit and the distributed unit, we have the front haul. Between the distributed unit and the centralized unit, the mid haul. And then from the centralized unit till the packet core, we will have the back haul. The connectivity is done in ORAN terminology, which is called transport network elements. That would be PE nodes in IETF terminology. And basically, just to mention, this association between the U and CU could be dynamic along the time. And this is precisely the kind of a scenario that we are trying to analyze here. So visually, looking visually to the figures, so essentially the DU could be either a physical appliance or an application running in a server, and then we have the possibility and the opportunity to connect to different CUs along the time. So depending on the specific needs, but also depending on the metrics that we could have in both network side and compute side. So basically, this is the problem space that we are covering here. So moving forward and more entering into architectural details, looking at what ORAN architecture is being defined, we have in ORAN an orchestrator, which is called SMO, Service and Management Orchestration, that basically interacts with the different functional components of ORAN. In this case, we highlight here the DU, the distributed unit, and the centralized unit. Because these units, these functions could run in virtualized environment, the entity, the management entity in charge of controlling that is called OCloud in ORAN terminology. So ORAN is defining different number of interfaces, O1 for controlling from SMO, the DU and the CU as functions, and then the O2 interface for interacting with the OCloud, that is basically the one managing the infrastructure, the virtualized infrastructure. Importantly here, for providing the connectivity, ORAN is considering now as well the TMN, the TNM, Transport Network Manager, and basically considering as well the need of a new interface, which is called identified there as TNMI. So precisely the scope of CATS will be in that part, so how to enforce the steering of between the functions and how to make it according to the status in both network and compute sites. So this is precisely the architectural thing that we want to develop in this document. And there are some implications in terms of architecture from CATS. One architecture is where to locate the path selector, because the OCloud will be the entity collecting the compute metrics. So it's an ORAN entity, but the network metrics will come from the TNM. So somehow we have difference, or the sources of the compute metrics and the network metrics are from different SDOs. So we need to understand what will be the position of the path selector, either in the SMO. This implies that the network metrics should go from the TNM to the SMO, or the path selector could stay in the TNM. This means that the TNM should have to receive the compute metrics from the cloud or directly or via the SMO. So in the regression, basically, what we want to analyze is this fact, so to understand the implications from the architectural case. And our next steps are basically to ensure that the metrics and requirements of the previous versions of this draft go to the adopted document here in CATS, but continue analyzing the architectural implications in this specific document, so being much more focused on architecture. Our idea would be to prepare a new version for next IETF with much more details. And also we consider that adopting the document could help to do this work together with Orange, so having a kind of liaison with them will probably speed up, let's say, the work on this. And that's all from my point. Well, from my side, sorry. Thank you.
Aha, this motivation is working well. Shang, we are next up.
Okay. Hello, everyone. This is Xiang Liu from Pengcheng Laboratory, China. And so on behalf of my co-authors, I'd like to present our DNS-based service discovery for CAS. The next slide, please. So first is the brief introduction. So as we reviewed just, key requirements of CAS framework is to provide a discovery and the resolving method for the mapping of a service identifier to a specific address. So DNSSD, which exactly provides a standard mechanism for that functionality, service discovery and the resolution. So based on that, we propose to extend DNSSD to fulfill the CAS requirements and integrate with the CAS framework. Next slide, please. By using the DNSSD mechanism, so the service instance name can be interpreted as this format. The first part is the instance name, and the second part is the service type, and the last part is the domain name. Next slide, please. And some other colleagues just also mentioned that whether to standardize the format of the metrics, right? So DNSSD also provides a standardized format for which is the TX records to advertise the metrics of a service, and we can using TX records to advertise all of those metrics. The next slide, please. Okay, so in DNSSD, for each service instance, we can provide the service records that can be published in this format, which is instance name and the domain name and priority weights and port number and the target. So to publish a specific record for a service instance. Next slide, please. About how to integrate with the CAS framework, and this is a very high-level diagram. And we have if we have a CAS clients and the CAS service, which and we have a DNS system, and the CAS service can publish or advertise their service by using a service registration request to the DNS system. So the DNS system can record the service and the service instances. And for the CAS clients, if a CAS client want to request a specific type of CAS service, it can send a service discovery request to the DNS system along with the specific requirements. So the DNS system can resolve the destination IP addresses and the port numbers and some others for the specific CAS service instance, which can meet the requirements of the CAS clients and provide that IP address and port numbers to the CAS framework for the traffic steering. Next slide, please. For the overall workflow, and the first phase is the service registration, and the service can use the DNS updates commands to dynamically update the IP address and the metrics and some other status of some service instances. And the second phase is the service discovery phase. The clients can use the DNS query commands to find the specific service instances from the DNS system. And the third phase is service selection phase, and in this phase, the DNS system can provide the IP address and port numbers and some others parameters to the clients, and using this, the clients can establish a connection with the service and do the traffic transmission. Okay, next step, please. Okay, thank you, this all. Thank you very much.
Thanks, Jim. Go for it.
Thanks very much. This is a very interesting idea, and I think it's to be commended that you're trying to use the DNS and the following mechanisms suggested by the DNS SDE working group. However, I'm sorry to say there's a lot of work needed on the DNS side of this particular draft. There are a lot of gaps. There are a lot of things that haven't been properly thought out, and they need much more work. A simple thing, for example, is you're suggesting using a text record. Why not use a discrete resource record type? Text records get abused for all sorts of things. To my mind, it's better to have a discrete resource record type to get this kind of information that you want. There's a lot of concerns around things like name collisions when you're trying to do dynamic updates. You've not really given a lot of thought so far in the draft about how you're going to authenticate those dynamic updates. And you've got issues then about key management. Are you going to use a shared key? Are you going to use unique keys for each of these particular clients when they're doing the updates? You also have to think about what you have to do when you want to delete those dynamic updates from the DNS, because just making an update to add something is fine. But what do you want to do when you want to withdraw that service announcement? You have to make a corresponding change to the DNS. The draft says nothing about that. There's a lot of more work to do there. I think you also need to look into a lot of the operational considerations about how frequently is this data going to get updated? What kind of capacity can you expect a DNS server to really handle in terms of updates and propagation times? Because once you update a DNS server with new data, that has to be propagated to all the other DNS servers that serve that particular zone, and how quickly can that be done too? There's a whole bunch of stuff in there that needs to be considered, and it's not really mentioned in the draft at this stage. I think you should need to go back there and do a lot more homework on that before you come back with an updated draft. Thanks.
Okay, thank you for the suggestion. And sorry, so I will contact after this meeting. So it is a lot of information that I cannot handle them all currently. So I will contact you after this meeting. Is that okay?
Yeah. Yes, that'll be fine. And also I can have a chat with Tima. I know him through the DNS Directorate, but happy to have a follow-up conversation. We can't do it now because we don't have the time.
Okay, thank you very much. Thank you very much.
Thanks, both of you. Genji.
Good morning, Tianji and Peng from China Mobile. Here, this just it's a large topic, but here, since we have only a couple of minutes, I will just make it very simple. This is I'll try to talk about some reference model based on the AI agent, and then from there we introduce the AI agent communication network. Can you go to the next one? Yeah, well, this is agenda. We can skip through, and the next one. Yeah, here just talk about what is the AI agent. You know, you can read through. It's very self-explanatory, and what is like AI agent, a software-driven entities, and that can be instantiated as either the physical or hardware. And then for that things, we got ACN, like AI agent communication network, can consider like a network that interconnect different AI agent to communicate, and then to form a group, networking group to do something. Okay, called ACN. Next. Okay, here is like a realization model for the communication among different AI agents to form the ACN network. There are 3 different models, like a static intra-domain, and then static inter-domain, and a dynamic multi-domains. Basically, this is like the form group, networking group to fulfill some tasks. Like if you have a complicated task, and to divide it into subtasks to work on. Okay, can you go down? Next one. What is the relationship or connection with the CAS here? Because for the AI agent is split into different a complicated task to be split into different subtasks, and then different things. Well, this basically like case one, case two here, and then something can be done locally, but something cannot, has to be done remotely in the cloud. But for cloud, of course, you're going to have a relatively long delay or long latencies. Of course, there are more cases from the 3GPP point of view, like ambient IoT and ISAC. Carlos mentioned already, and the XR rendering has been described by a previous author. The CAS metric model here was just to try to introduce the networking metric, a compute metric that the existing things here is like an AI agent matrix that is to be associated with the capabilities or capacity, all kind of things related to AI agent. That is something new. I'm not going to introduce this one to the metrics of the CAS, the document itself. Don't worry about that things, Chen. I know you're going to ask. But here, just to try to give this one to justify why we need to get some reference model. Can we go down? Yeah, here just to give, okay, well, what is like the protocol stack if we introduce the asymmetric, but this is just like a concept or term used to introduce the reference model, not going to influence your CAS metric. Okay, here there are different layer protocol stack, like the existing one consider on the more for the extension from the protocol, networking protocol extension to do the work. And then, but for ACN, it's like a more toward the app level. Can you go to that? So in order to do all kind of things here, but on the left side, starting the cloud and also the inside. On the right hand side is what we have right now to communicate, but introduce the AI agent on that part, we're going to have a more complicated. So that's why, can you go down to for the final one, it's just a give, okay, we have a lot of thought in the draft, more probably people can read it. And we define a reference model with a reference points and a reference interfaces for the ECM, and give what is service model, the interface, signaling process, procedure, overlay, and communication channel, all kind of things. Yeah, can you go to the next one? And just it. So we'll just try to introduce the reference model. So, that's it. So I just fly through it. So more details in the draft. Thank you.
You completed on time. But Chong, sorry, we are genuinely out of time for the meeting. So talk offline or talk on the mailing list.
Just one suggestion, you can send the question to the mailing list about AI agent metric. That would be very interesting.
Yeah, okay, sure, thank you.
Okay, thank you all for squeezing that all in. See you on the mailing list, most importantly, and then see you in Montreal if we can make it.